Who could tell me what this is?
The pH scale.
Good, the pH scale. Anybody know why it's called the power of hydrogen? What happens when water disassociates? We talked about this yesterday. What does it produce?
Hydrogen and
Hydrogen ions and hydroxide. So basically the pH scale is called the power of hydrogen because it's going to look at the concentration of hydrogen ions and hydroxide ions. So who could tell me any about my ABCs here?
A is acidic, B is basic, and C is neutral.
Good. A is acid, B is basic, and C is neutral. Who could tell me something about neutral?
Only water.
Only water is neutral. Pure water, I should say. I've tested water year after year after year. Rarely do I get a reading of 7 unless if we created like pure water in the lab or I bought pure distilled water. Why do you think water never comes out of 7?
Because there's usually like other stuff mixed into it.
There's some impurities always in there. Your sink is made of pipes. You're going to get some kind of, mix. You buy water in a plastic water bottle. There's made out of plastic. Plastic has materials or compounds, so there's some kind of mixing. Rainwater is never pure either. So, all right, if you're an acid, what numbers are you on the pH scale? Who could tell me that? 0 to 6.999, let's say. All right, we'll put the line on top. If you're a base, we're going to say 7.0000, right? 1, 2, 14. So the pH scale is from 0 to 14. Now back to the power of hydrogen versus hydroxide. If you're an acid, what do you have more of? Hydrogen ions or hydroxide ions? Anybody know? If you're an acid, no, at least you guess. If you're an acid, you're going to have more hydrogen ions. If you're a base, you're going to have more hydroxide ions. What's more acidic? 3 or 5? Raise your hand if you can answer that. 3. The lower you go, the more of an acid you are. So a pH of 0 is much more acidic than a pH of 4. Okay? If you go this way, what happens? Raise your hand if you can tell me that.
The more basic you get.
The more basic you get, and the more what?
More non-acidic.
The more non-acidic, good, and the more what? Think of what I just referenced.
The more oxygen hydroxide.
Hydroxide ions, okay? The more basic you are, the more hydroxide ions. The more acidic you are, the more hydrogen ions, okay? We're going to do a lab tomorrow on pH. Yesterday we talked about compounds of life. Our first, which was it? Raise your hand if you could remind me. It was just yesterday. The compound that is essential to life, water. It was an inorganic compound. Why? It didn't have at least 2 carbons. In order to be organic, you have to have at least 2 carbons in your chemical composition. We are going to learn 3 organic compounds for this unit. All 3 of those compounds are called macromolecules. What does that mean? The word macro, what does that root word mean? Raise your hand if you could tell me that. I'll help you. What does micro mean? So what does macro mean? Big, large, big, organic compound molecules. They're huge molecules. Now, obviously, we know they're going to be made up of at least 2 carbons. But a molecule is a combination of atoms between 2 elements, okay, that share or transfer electrons. What other elements make up organic compounds. Carbon is going to react with what to make up an organic compound? Try to think. Give me elements that you know on the periodic table that react with carbon. Hydrogen. Oxygen. Nope. It can. It's just not going to be mainly an organic compound. Because calcium carbonate reacts with. So we've got carbon, hydrogen, oxygen. Anybody? No, but you're on the right track. I'll show you the letters and somebody raise your hand and tell me what that is.
Nitrogen.
Nitrogen. What's this? Phosphorus. And what's this? Sulfur. I'll write them down for you because you have to know them. Sulfur. Phosphorus. Nitrogen. Oxygen. Hydrogen. And carbon. Word, look how I wrote the word carbohydrate. Okay, process that for a minute. For every organic compound, the three that I'm going to cover what they're made up of, what builds them, because each compound is actually made up of blocks of the same thing over and over and over. Okay, a lot of them because they're big molecules. What their function is, examples or types. Okay, so based on the carbohydrate wording, what is a carbohydrate made up of?
Carbon, oxygen, hydrogen.
Correct. I put CHO here because I'm going to keep it in the order of CHON PS or CHOMPS. Had anybody ever heard that before? Those are your elements of organic compounds. CHON PS or CHOMPS. So CHO. Now, a carb is always going to have a 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. Who could tell me what that means?
There's one carbon, two hydrogen, one oxygen.
Good. For every one carbon, there'll be 2 hydrogens and 1 oxygen. But we know that an organic compound has to have at least 2 carbons, right? So what's the rest of the formula? Who could tell me? If I give you C2.
It's gonna be 2 carbon, 4 hydrogen, and 2 oxygen.
So you're going to say C2H4O2. Okay? I'm going to show you again. If I give you C3, what are you going to tell me about H? Raise your hand if you could tell me that.
H6.
H6. O3. For every 1 carbon, you're going to double the hydrogens and the oxygens match the carbon. So now I'm going to ask you, if I give you C4, what are you going to give me? C4.
Multiplied by 2, so
H8.
and O4. I can see 4.
No, O4. CHO. Good. So I can give you any number. You're going to double the hydrogens and keep the oxygens the same. Or if I give you the hydrogen, let's try that. H16. C8. And oxygen 8. Okay? All right. Now, what is the function? When you think of a carbohydrate, tell me anything that comes to your mind. If you think of a carb. No? Food. What kind?
Fattening.
Fattening.
Like grains.
Like grains can be. Sugar. The building blocks of carbs are actually sugars. They're made up of sugars. A lot of sugars, a little bit of sugars, it doesn't matter. The building block of a carbohydrate is 1 sugar, or 2, or 3, or 4. What's the function of a carbohydrate? What do they do for you?
Provide energy for the body.
Energy, but it's quick energy. It's not long lasting. It's like a rush of energy and then you crash, right? Has anybody ever seen that movie with, there's two main types of carbohydrates. We know one is sugars. Anybody know what the other one is? You studied it when you studied cells.
Protein.
No, that's a whole other topic. Plant cells in particular. No, good answer though, because when you think of a plant cell, it's cellulose. I'm not going to tell you any more about that now. We later talk about cellulose because we talk about cells and their structures. And it's not just plants, it's more than just plants. But. All right, there's types of sugars. Has anybody ever seen the word saccharide? Anybody know what comes with those words? So if I tell you a simple sugar, I'm basically referencing one. So what's a root word in science that describes one? Or a root word in Latin? Mono. Good. Later, you can have a carb made up of two sugars. Poly is many sugars. What's two sugars? Bi is good. What's another one? That describes two. Not bi, but di. Disaccharide. All right, if we look at my pictures, let's start with this one. Who could tell me something about glucose and fructose that they have in common? Based on what you just read. It's a carb. What kind? What type of carb? Yes? Simple. What do we call simple carb? It's a monosaccharide. It's made up of only one sugar, one building block. Look at the difference here. You see the di? Two. Poly, anything more than two makes up a poly. Everybody see that? You see right here? 1, 2, 3, 4. So I can ask you questions on the test. What type of carb is this? You could tell me